Good day, viewers all over the world. Today we want to look at examples on Wronskian. So we are starting with this first example, where we are asked to find the Wronskian of the sets as we have it on the board. So if you check the video on how to find the Wronskian, you realize that if you want to find the Wronskian of this set, just say W of EX E minus X. Okay, that will give us, that simply means that if you want to find the Wronskian, Wronskian of a set, it possesses the n minus 1 derivative on the interval of that set. So the Wronskian of this set will be, the Wronskian of this set will be, we first write the set, e raised to power x, e raised to power minus x. Then we go ahead and find the derivative. No, we have just two. We have two here. So we'll stop at the second as the first derivative. If we differentiate e raised to power x, that will be e raised to power x. If we differentiate this, we are going to have minus e raised to power minus x. Then we find the determinant. The determinant, of course, we know what to do. When we are asked to find the determinant, we know what to do. When we are asked to find the determinant. I hope you understand what I've done here. Okay, I can repeat it here and say, this is the hex of e raised to power x, then the hex of e raised to power minus x. This is what I've done here. That's how to find the Wronskian. If it's more than 2, it's 3. We go ahead and find the third derivative. Then if we do that here, that will be e raised to power x, e raised to power minus x. If we differentiate this, it's e raised to power x, then minus e raised to power minus x. That's what we are going to get. Okay? So if we define the determinant, what are we going to get? Determinant simply means this multiplied by this. That is determinant. That is how to find the determinant. That is how to find the determinants. So if you do that here, we are going to have minus e raised to power x multiplied by e raised to power minus x, then minus e raised to power x multiplied by e raised to power minus x. So what do we get if we do that? That will be minus log indices. The bases are equal. When we had this, we are going to get 0. Minus 0 minus e raised to power 0. That will be n raised to power 0 is 1. So we have minus 1 minus 1. At the end of the day, the final answer will be minus 2. The final answer will be minus 2. So minus 2 will be the final answer that we are going to get there. Minus 2 will be the final answer that we are going to get there. So the Wronskian of that set is equal to minus 2. Okay. Then of course we can be asked to determine whether the set is linearly dependent or linearly independent. So if you go through the lectures, the lectures that we had the last time, you should be able to find if that Wronskian is linearly dependent or linearly independent. So it is possible we can be asked to show if the Wronskian is linearly dependent or linearly dependent. So in this case now, the Wronskian of this set was found to be minus 2. So, and since it is non-zero for at least 1 point, it is not zero for at least 1 point in that interval of interest. So the set is, in this case, the set is said to be linearly independent. The set is said to be linearly independent. That is that about that. So let's take another example. Let's take another example. So in this case now, so the question says two solutions of the differential equation minus 2y prime plus y squared equal to 0 are e raised power x and x e raised power x. That is the question. Two solutions of the differential equation is what we have on the board. E raised power x and e raised power x e raised power x. So the question now is that is the general solution y is equal to c1 ex plus c2 e c2 x e x. That's the solution. How do we determine if this is the general solution? Of course, if you want to know if this is the general solution, we go ahead and find the Wronskian of these two solutions. And if it is zero, if it is non-zero, it shows that the two solutions are linearly independent. And once they are linearly independent, that can actually guarantee that there are solutions to that differential equations. So what do we do here? We go ahead and find. We go ahead and find the Wronskian of the two solutions. The first one is e raised power x, comma x e raised power x. Of course, I want to believe that we know how to find the Wronskian now. I want to believe that we know how to find the Wronskian. What we are going to do then is that we first write the solution. That's the first one, e raised power x, x e raised power x. Then the second one, we differentiate this, the first derivative, because it's just two solutions. We differentiate this, it's the same thing. If we differentiate this now, here there are two things involved. If we differentiate this first one, notice product rule between polynomial function and exponential function. Let's differentiate this. We pick this. At least, if I pick this, I'll differentiate this. So this will be x e s plus I'll come back and pick this and differentiate this. That will be e raised by s. This is what we are going to have. At the end of the day, what will be the value of the Wronskian? This will multiply this. We have e raised by x into bracket x e raised by x plus ex minus x e raised by 2x. Okay, e raised by x multiplied by e raised by x. So from there, what do we get? From this point now, what do we get? We are going to multiply through. We are going to have x e raised power 2x plus e raised power 2x minus x e raised power 2x. This can take care of this. At the end of the day, the final answer will be e raised power 2x, which is not equal to 0. Okay, that's also what you are going to get. It's not equal to 0. So it follows that the two particular solution, this is non-homogeneous equation. This is homogeneous equation because this second order differential equations, the right hand side equal to 0. And whenever you have nth order differential equation, whereby the right hand side is equal to 0, it is called homogeneous equation. And such equation only has one solution, which is called the complementary solution. And these are the solutions in this case that were given. So the general solution will also be the complementary solution. So in this case now, since the Wronskian is non-zero, is not equal to 0, it follows that the two particular solutions are linearly independent. And the general solution is actually right. So the general solution, so the two particular solutions are linearly independent, and the general solution will be C1 E raised by x plus C2 x e raised by x. So this will represent the general solution. So from the question now, is the general solution equal to this? Yes. The answer is yes. Because when we find the Wronskian, it is non-zero. And whenever we have the Wronskian to be non-zero, it shows that the solutions are linearly independent. So the general solution is what we are given. You have been able to verify that. So I would love to stop here because of our time. We continue from there in the next class.